بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 2.8. Find the derivative of the function using the definition of derivative. State the domain of the function and the domain of its derivative. Well, you remember, or uh, anyway, the derivative of the function by definition is limit when h approaches 0 of f of x plus h minus f of x over h. Well, f of x is given in the question, so this is f of x equals mx plus b. And to find f of x plus h, we replace x by x plus h. So we will have m, and instead of x, we write x plus h plus b. So f of x plus h would be mx plus mh plus b. So now to find the derivative using the definition, this is limit when h approaches 0 of f of x plus h, which is mx plus mb plus b minus f of x. And when we subtract, when we multiply f of x by a negative sign, we will multiply mx by negative, and also we will change the sign of positive b to negative b. So here, negative f of x over h. Now you notice that b cancels with b, mx cancels with mx, and then we have limit when h approaches 0 of mb over there is something here wrong. Yeah, this is mh. This is mh. Okay, because always h should be cancelled with h to be able to replace the limit by 0, replace h by 0. So this term is mh, and h cancels with h, and now limit m when h approaches 0 is m, so f prime of x is m, where m is a constant. M here is just a number. So the domain of f is a straight line, so the domain consists of sets of all real numbers, and f prime also constant function. It's a constant function, equals m, y equals 2, for example, or 3 or 4. So it's a constant function, and the domain is also set of all real numbers. And this makes sense because mx plus b is a straight line, and the slope of the straight line is m. And the derivative is the slope of the tangent line. So the tangent line to the straight line is the straight line itself. So the slope should be m, which is the derivative. Same question, but with another function. So f of x plus h here would be 4, there is no x, plus 8 times x. Any x, I replace it by x plus h. Minus 5 times, I have x squared, so I replace x by x plus h. Now f prime of x would be the limit when h approaches 0 of f of x plus h, which is this one. Okay, I'll start to expand. So 4 plus 8 times x plus 8 times h minus 5 times. Now expand this. X plus h to the power 2 gives x squared plus first term squared, 2 times the first times the second, and the second term squared. This is how we square a binomial. Well, minus, and let me write 4 plus 8x minus 5x squared. So this is f of x plus h minus f of x over h. And now we continue expanding. So I have 4 plus 8x plus 8h minus 5 times x squared minus 5 times 2hx and minus 5 times h squared. And this negative will change all the signs inside parentheses. So negative 5 would be positive 5x squared over h. And now 4 cancels with negative 4. 8x cancels with negative x. Negative 5x squared cancels with 5x squared. And we have the remaining terms with h in each one of them. So 8h, there is an h here, and negative 10hx has h, and negative 5h squared has h squared. We cannot cancel. To cancel, we have to take h as a common factor from the numerator. So we have 8 minus 10x minus 5h over h. Now h cancels with h, and we can replace h by 0. So I have 8 minus 10x minus 0. So that's the derivative. So f prime x is 8 minus 10x. F of x is a polynomial. F prime is a straight line. Both are polynomial functions. So domain of f is equal to domain of f prime consists of the set of all real numbers. Here we have a rational function, and we need to find f prime of v. Well, f prime of v would be the limit when h approaches 0 of f of v plus h minus f of v over h. And to find f of v plus h, we replace v by v plus h. So v, I write v plus h. Over v, I write v plus h. And I put the 2. Okay, so this would be limit h approaches 0. H is in the denominator. I will take it out here. Okay, and then f of v plus h is v plus h over v plus h plus 2 minus f of v, which is v over v plus 2. And now how to add these two fractions? Well, the formula a over b minus c over d equals b times d. You multiply the denominators, and then a times d minus b times c. This is how we add two fractions. So we will have the limit when h approaches 0 of 1 over h times. Now we need to add these two fractions, because at the end I need to cancel this h, and I cannot cancel if there is a minus here. How to add? The formula is written here. So we multiply the two denominators, and v plus h is multiplied by v plus 2. Let us do it. Let us expand. V times v is v squared. V times 2 is 2v. H times v is hv. H times 2 is 2h. And now minus v times this. So minus v will be multiplied by these three terms. And there is a negative sign always. So negative v times v is negative v squared. Negative v times h is negative vh. Negative v times 2 is negative 2v. And that's it. Okay. Let me make this smaller. All right. Now, any cancellation, yeah, v squared cancelled with v squared. 2v cancels with negative 2v. vh cancels with hv. And I just have 2h in the numerator. Well, now I can cancel h with h outside. Okay. Let me write it like this. So you know that we cancel h with h when we don't have any addition or subtraction in the denominator. So now I can replace h by 0. So I have 2 in the numerator, and here v plus 2 times v plus 2, because h is 0. So the answer is 2 over v plus 2 to the power 2. So that's the derivative of this function. Now look to f. What is the domain of f? Well, the domain of f consists of all real numbers except -2, because we do not allow the denominator to be 0. And -2 will make the denominator 0. What about the domain of f prime? This is f prime. Again, we have v plus 2 to the power 2 in the denominator, and if v is -2, the denominator would be 0. So the domain of f prime also consists of all real numbers except -2. We need to find g prime of x. Well, I need g of x plus h, which is 1 over 1 plus square root of x plus h. So I replace x by x plus h. So g prime of x would be the limit when h approaches 0. G of x plus h, okay, which is 1 over 1 plus x plus h minus g of x, which is this one, all over h. So to have a nice fraction, I take 1 over h outside, okay, and I add these two or subtract these two fractions, again using the same method. So I multiply the denominators. And then 1 times 1 plus square root of x minus 1 times this, so minus 1 minus 1 times square root of x plus h. Now 1 cancels with 1. And how can I proceed? How can I continue? Well, I will multiply. I have square root of x minus square root of x plus h in the numerator. So I will multiply by the conjugate. In the denominator, I have these two. I will multiply by the conjugate of square root of x minus square root of x plus h. So I change the sign in the middle. Okay, you know, u minus v times u plus v equals u square minus v square. So u plus v is the conjugate of u minus v, and u minus v is the conjugate of u plus v. Whenever one of them is a square root, we need to multiply by the conjugate. So when we multiply, we raise it to the power 2, and we get rid of the square root. So we have 1 over h. And now when we multiply these two fractions, remember, you multiply fractions like this: a times c and b times d in the denominator. So if you multiply the numerator times the numerator, you get u squared minus v squared. So square root of x squared, that's x, and square root of x plus h squared, that's negative x plus h. And I have here 1 plus square root of x, 1 plus square root of x plus h times square root of x plus the square root of x plus h. Now notice that when I multiply by negative, x would be cancelled with x, and I'll have a negative h in the numerator. So there is a negative h here, because this is x minus h over the denominator. This is plus. Okay, you write the denominator as it is. And now h cancels with h. And you can replace h by 0. So what would you have? In the numerator, I have -1. In the denominator, I have 1 plus square root of x. There is no h here. Well, here, I replace h by 0. So I have 1 plus square root of x. And here I have square root of x. There is no h. And here, I replace h by 0. So I have square root of x. So what is the answer? Negative 1 over. I have 1 plus square root of x all squared. And when I add square root of x plus square root of x, I have 2 times square root of x. So this is the derivative of this function. Now, what is the domain of g of x? Well, x has to be greater than 0 because it's inside the square root, and it cannot be it can be 0, there is no problem. The denominator cannot be 0. Notice that the denominator here will never be 0 because if you solve this equation, you take negative 1 to the other side, it would be negative 1, and square root cannot be negative, so this denominator cannot be 0. So we can say that the domain of G consists of all real numbers from 0 to infinity, included the 0. If you put x0, you get 1. You cannot choose negative numbers because square root of x will not be defined. While here, the domain of G prime, this is G prime, I cannot allow x to be 0 because here it's okay, 1 plus 0 is okay, but here, square root of x, if you put x0, this would be 0 times anything, so the denominator would be 0. So the domain of G prime would be 0 to infinity, but open from 0, means 0 is not included, is not in the domain of G prime, while it is in the domain of G. Well, this is a graph of a function. State with reasons the numbers at which f is not differentiable. Okay, at negative 1, it is not differentiable at negative 1 because it's not continuous. Okay, you see it's not continuous because the limit exists, but it doesn't equal to, it's not equal to f of negative 1. Okay, here at 2, because there is a corner. Okay, so we have seen whenever there is a corner, the derivative does not exist because I cannot define a single tangent line. There will be infinitely many tangent lines here. Well, in question 43, at 1, it's not defined. There is a vertical asymptote here. So it is not continuous. I can say f is not continuous because it's not defined. Also, here at 5, okay, there is a vertical tangent line. We said if there is a vertical tangent line, the slope of the vertical tangent line is infinity. So this is 5. If you try to sketch a tangent line at this point, it would be a vertical line. Here at negative 2, there is a corner. At 2 also, at 3, okay? At 3, there is also a corner. And at 1, f is not continuous. So 3 numbers here, f is not differentiable at them. Well, here find f prime of 4 from the left. Okay, the definition of f prime of 4 is can be written using 2 definitions, if you remember. I will use this definition. It is limit when x approaches a, or 4 here, of f of x minus f of a, or 4, over x minus 4. So this is f prime of 4. F prime of 4 from the left, okay, would be the same limit, but we approach 4 from the left. All right, so in this case, f of x, what would be f of x? To the left of 4, we are here, so the definition is 5 minus x. And what is f of 4? Well, f of 4 always, because the equality is here, so always f of 4 is 1 over 5 minus 4, which is 1. So f of 4 is always 1 in this question. So minus 1. over x minus 4. 5 minus 1 is 4 minus x over x minus 4. We can cancel these two because the difference between them is -1, and the limit of -1 would be -1. So the left derivative of the function at 4 is -1. Let us find the right derivative. Here we approach 4 from the right, and f of x would be 1 over 5 minus x. Okay, minus f of 4, which is 1 over x minus 4. I applied this definition. I can take 1 over x minus 4 outside like this, and I can add or subtract these two fractions using the same formula we did just 3 minutes ago. So we have 1 times 1 is 1 minus 1 times 5 is -5 minus 1 times -x is positive x. Now I have 1 over x minus 4. I can say that x minus 4 and 5 minus x, I can multiply them like this, no problem. And I have in the numerator 1 minus 5, which is -4 plus x. Now, if you look carefully to -4 plus x, it's actually x minus 4. So I can cancel x minus 4 with x minus 4, and I have 1 in the numerator. And if I replace now x by 4, I'll have 5 minus 4, which is 1. So the derivative from the right is 1. So the derivative from the left is not equal to the derivative from the right. So this means that f prime of 4 does not exist. Okay, the derivative at 4 is not defined. Sketch the graph of f. Okay, f is a piecewise function. It has 3 definitions. What are the important points? 0 and 4. 0 and 4. So 1, 2, 3, 4, x. This is x, 0 and 4. Now look. To the left of 0, when x is less than or equal to 0, the function is 0. So y equals to 0. What is the graph of y equals to 0? It is this line. And this point is included. Okay, so this is the graph when x is less than or equal to 0. Between 0 and 4, we need to graph y equals 5 minus x. So y equals 5 minus x between 0 and 4. It's a straight line, so I replace x with 0, I get 5. And at 0, it is an open circle because we have the closed circle with this part because the equality is here, not here. So f of 0 is 0, not 5. All right. And if I replace x by 4, 5 minus 4 is 1 here. And also I put an open circle, and this is the line connecting, excuse my graphing. This is the line connecting these 2 points. So this is the graph of 5 minus x. Now, greater than or equal to 4, I need to graph 1 over 5 minus x. So y equals 1 over 5 minus x. I need to graph it here. Well, for this function, this is a rational function. The domain, all real numbers except 5. At x equals to 5, there is a horizontal asymptote. So at x equals to 5 here, there is a horizontal asymptote of the function y over 5 minus x. So let me check at 4. Of course, I take table of coordinates. At 4, 5 minus 4 is 1. So at 4 it is 1. So at 4 it is 1. So this circle now will be closed because it will belong to this function. And at 5 I cannot choose. So if I choose at 4.5, okay, 4.5. 5 minus 4.5 is half. 1 over half is 2. So at 4.5, it is 2 here. Okay. So it goes like this because it will approach the vertical asymptotes. And notice that now here we have a corner. At 4, there is a corner because the function was coming like this, and then it continued like a straight line. It continued on a straight line. All right. So there is a corner here, and that's why the derivative is not it does not exist at 4. So this is the graph of this function, but let us also continue. So here it is 2, here it is 1. Let us take to the right of 5, which is 6, for example. At 6, what happens? At 6, 5 minus 6 is negative 1, so it's negative 1. So at 6, it is negative 1. Notice also that this uh, rational function, this is the vertical asymptote, and the horizontal asymptote is y equals to 0. Okay, because when you find the limit when x approaches infinity, 1 over infinity would be 0. So y equals to 0, this line is a horizontal asymptote. Okay, so now you can sketch the graph of the function. It will uh, approach the vertical asymptote, and it will also approach the horizontal asymptote. So this would be the graph of this function. Notice that at 0, it's not differentiable because it's not continuous. At 4, it's not differentiable because there is a corner. At 5, it's not differentiable because the function is not continuous or not defined. So where is f not differentiable? 0, 4, and 5. So 0 and 5, f is not continuous. At 4, there is a corner. Where is f discontinuous? F is not continuous at 0 and 5. Of course, at 4, it is continuous. There is no problem, but there is a corner, so it's not differentiable. That's the end of these exercises. Hope you enjoyed. Have a nice time and study hard.